Assalamualaikum. This is our group project presentation, which is car parking sensor. First of all, I would like to thank Mr. BADARUDDIN bin Mohamed for teaching us embedded controller technology. I will be presenting the introduction part, block diagram, and conclusion. So we'll go to the introduction. Okay, a car parking sensor is designed to detect an obstacle that blocks the path of the car during reverse parking mode. This feature helps the driver by notifying them when their car have reached a certain distance that already been set. Okay, and then we go to the block diagram. Okay, as you can see here, this is our block diagram for this project. We use STM32F1036C as our microcontroller. To power up this system, we use battery as our power supply, and then we use two switch as two digital switch. The first one to indicate the reverse of the motor, and the second one is to indicate the forward of the motor. Okay, we use GP2D12 distance sensor as our car parking sensor. The distance of the sensor can be set, and so this sensor will send a signal into the microcontroller, and then the microcontroller will read this signal and send the data to the output set. The output set here is DC motor. For DC motor, the driver motor will what we call this, we control the speed of the motor. So the output here will be the 4 DC motor. Okay, and the I forgot one more thing, which is LED. LED also will light up.
So we will move to the flowchart of the program, and as you can see, first and foremost, we have to turn on the clock for ADC1 and GPIO A and B. So next we have to set switch 1 and 2 at GPIO B, which is when the switch 1 is pressed, and it indicates that the motor is driving forward, and the virtual terminal will display the message of the car is driving forward. And if both switches are not pressed, it is in default mode, which is the motor are not driven to any direction. It means the motor will remain at static motion. I mean no motion at all. And if the reverse switch 2 or reverse switch is pressed, or in other words, we can say the reverse pedal are pressed, it means the motor driving reverse, and it will move to the function A. You can see the function A is, and this is our function A, and GP2D12, which our sensor will read the analog value and convert it to the distance and also the voltage value. And so this is the voltage formula for this sensor, which is 5 times analog value divided by 40696, which equals to 12 bit. 2 to the power 10 of 10 power of 12, and the analog value can also convert to the distance, which is 29.4633 times 4096 divided by 5 times analog value read by the sensor. Where I get this value, I will show you later. And they will print voltage and also print the distance value on the serial monitor, and it will go to the function B. And next, if the distance is more than 60 cm, I forgot to tell you one important thing, that the sensor can read from 10 cm up to 80 cm only. So if the distance is more than 60 centimeter and less than 80 meter, it means that motor is driving reverse, of course. And since we are focused on the reverse system, and the message will be displayed of warning, and the LED will blink were playing for 200 millisecond delay. And if the distance is more than 25 centimeter and less than 60 centimeter, that means the message will be warning you are closing and the LEDs will blink 50 milliseconds delay. And if the distance is, I made a mistake here, and if the distance is less than 25 centimeter, okay, this is wrong, this is correct. So the car will stop and the motor will stop driving. That means no motion on the motor and the LEDs will blink 0 millisecond delay. So I'm sorry for the mistake. So the result is this is our schematic diagram on the Proteus, and the discussion. Let's move to the discussion first before I show you the result on the Proteus. So this is our calculation where I researched on Google a few articles I read, and this is the real distance in the GP2D12 sensor, which is 10 up to 80 centimeter, and this is the analog value, which is the maximum of 190, 26 and 333, and this is the voltage value, and this voltmeter times centimeter. By that we can get this value, we add up together and we get the mean value divided by 15, we get the 29.463. This is what I meant before in the flowchart. So this is the distance. I mean the mean value were times by 12 bit and divided by 5 volt times analog value. So the Vout will be 5 volt times analog value divided by 4096. So this is the graph which is matched with the sharp the sensor on the sharp manual of the GP2D12. This is the distance we calculated. You can see the deviation of the 2 centimeter on the first. If you want to calculate the 10 centimeter, you will get 12.50.186 if you set it on the Proteus. And this is our calculation up to the 80, you get 72, and this is the real distance. Okay, now I will show you on the Proteus. It's already play, and if I press forward, it show that the motor is driving forward and the message will display car is driving forward. So this minor thing that we want to show you about. The major thing is the reverse pedal. So the reverse pedal, you can see that the distance now 33. If the distance 33, you can see that I'm sorry, if the distance is 35, the voltage will be 35.13, 35.442. We will get 35.65, and the voltage value will be 0.84, 0.83. Okay, it matches what we have calculated before. What if I set it below 25? I want to set it below 25. If I want to set below 25, it means I have to set it to 20 maybe. It will display the distance 22.28 and the volt 1.32 volt. 20. It takes time to process, to send the data. As you can see here. So the reverse pedal is pressed, but the motor is not. It's not driving. It will stop. You can see the message is stop. Car stop here, and the distance is 22.31. 287.287. 286. Yes, it matches what we have calculated, and the voltage will be 1.32. 1.32. Yes. So this is the what we have designed the project based on the system we want to make. So the LED will blinks with no delay. And one more thing, if the distance is more than 60 centimeter, which is here, let's set it to 70 centimeter, you will get 64.53. Do I get 64.13? And the voltage value will be 0.46. 0.46. Yes, I do get that. So this is our project, how the distance GP2D12 sensor will send the analog value to the microcontroller, and it will convert it to the digital output, which is our motor here, based on the control of the pedals we have pressed, either forward or reverse pedal. Okay, let's move to the conclusion will made by ASYRAF.
Okay, what I can conclude is this system can be implemented to all type of car, and with this system it can help to control the position of the car during parking, whether the car is properly parked or not. And from this performance evaluation, our system managed to give an accurate data during the parking mode. And then overall of our project, car parking sensor is completely success.
So I bid you thank you very much, and thank you for your attention and concentration. So I bid you a good day. Assalamualaikum
Thank you.
and very good evening.
Assalamualaikum.
Thank you very much.